Welcome again to Math 800 Pre-Algebra. Today we are doing Section 4.1, Introduction to Signed Fractions. Our objectives. 1. To use a fraction to name part of a whole. 2. To identify numerators, denominators, proper fractions, and improper fractions. 3. To graph positive and negative fractions on a number line. 4. To find the absolute value of a fraction. And lastly, 5. To write equivalent fractions. A fraction is a number of the form a over b, where a and b are integers and b is not 0. Here is an example of a fraction. A recipe uses 2/3 cups of milk. 2/3 is between 0 and 1. We need fractions because there are many cases where a whole number is not sufficient. In this case, if you were baking, 1 cup of milk would be too much, but you can't leave the milk out altogether. Therefore, you need 2/3 of a cup, which is between 0 and 1. 2/3 is a fraction because it is of the form a over b, and 2 and 3 are integers. The top number in a fraction is called the numerator, and the bottom number is called the denominator. Example: use fractions to represent the shaded portion and the unshaded portion of the figure. The whole circle must be divided into parts that are the same size. All fractions must use parts that are the same size. If they are not the same size, you are not dealing with a fraction. The whole circle has 3 equal parts, so our denominators will be 3. 2 parts of the circle are shaded, so the numerator for the fraction representing the shaded part is 2. 2/3 of the circle is shaded. The whole circle has 1, 2, 3 parts, so our denominator is 3. 2 of those parts are shaded, so our numerator is 2. 2/3 is shaded. 1 part of the circle is not shaded, so the numerator for the fraction representing the unshaded part is 1. 1/3 of the circle is unshaded. There are 3 equal-sized parts, so our denominator is 3. 1 part is not shaded, so our numerator is 1. 1/3 of the circle is unshaded. Use fractions to represent the shaded portion and the unshaded portion of this figure. This whole rectangle has 7 equal parts, 1, 2, 3, 4, 5, 6, 7, so our denominators will be 7. 4 of these parts are shaded, so our numerator will be 4. 4/7 is shaded, 1, 2, 3, 4 out of 1, 2, 3, 4, 5, 6, 7 total. 3 parts are not shaded, so the unshaded portion of the fraction is represented by 3/7. 1, 2, 3 are not shaded out of 1, 2, 3, 4, 5, 6, 7 total. This example is slightly more difficult. In this case, we have 2 separate rectangles. However, both rectangles are divided into 4 equal-sized parts. Since one whole rectangle has 4 parts, our denominator will be 4. Our denominator is not 8. The denominator of 8 would indicate one giant rectangle with 8 parts. This is 2 separate rectangles, and one rectangle has 4 parts, the second rectangle also has 4 parts, and all of those parts are the same size. All 4 parts of the first rectangle are shaded, plus an additional part in our second rectangle is shaded, for a total of 5 shaded parts, so our numerator will be 5. The shaded portion is represented by the fraction 5/4. 5 pieces are shaded, and one rectangle has only 4 parts, so our denominator is only 4. 3 parts of the second rectangle are not shaded, so the numerator for the fraction representing the unshaded part is 3, 3/4. If you are familiar with mixed numbers, you could also have written this as 1 and 1/4. We will talk about mixed numbers more in later sections. Use fractions to represent the shaded parts. Once again, we have a situation with 2 separate rectangles. One whole rectangle has 3 equal-sized portions, so our denominator will be 3. Notice the second rectangle also has 3 portions, and they are the same size. All 3 parts of the first rectangle plus 2 parts of the second rectangle are shaded, for a total of 5 shaded portions. The fraction representing the shaded amount will be 5/3. There are 5 shaded boxes, and one rectangle has 3 equal-sized parts. Only one part is not shaded, so 1/3 is unshaded. More with numerators and denominators. The denominator of a fraction shows the number of equal parts in the whole. The numerator shows how many parts are being considered. So far, we've only dealt with shaded and unshaded. That is what our numerator represented. But there are many applications where your numerator can represent other things. Here's an example of a fraction. The 2 is in the top, that is our numerator. The 3 is in the bottom, that is our denominator. The fraction bar is what we put in between them. Some people like to refer to it as upstairs and downstairs. If you like to use that to help you remember, that's fine, but you need to get comfortable with the notation and the words numerator and denominator. Those are the words the book is going to use, those are the words your teachers are going to use, and you need to be comfortable with them. The best way to get comfortable with new words is to use the new words. So I would encourage you to get away from using things like upstairs and downstairs and to start focus on the proper names, numerator and denominator. Recall that the fraction bar is just another symbol for division, and we can't divide by 0. Therefore, we can't have a denominator of 0. Example: identify the numerator and the denominator in the fraction. Then state the number of equal parts in the whole, and lastly draw a diagram representing the fraction. Our fraction is 5/9. The numerator is 5 and the denominator is 9. The denominator tells us there are 9 equal parts in the whole. If we were to draw a diagram, we should start with a shape. Rectangles are usually the easiest. And we need 9 equal parts, since that is our denominator. I now have 1, 2, 3, 4, 5, 6, 7, 8, 9 equal parts. You do not need to get a ruler out and have them perfect, but they need to be roughly 9 equal parts. Our numerator is 5, so we should shade in 5 of these boxes. This now represents the fraction 5/9. There were 9 equal parts in one whole, and 5 of them have been shaded. Proper and improper fractions. If the numerator of a fraction is less than the denominator, the fraction is a proper fraction. A proper fraction is always less than 1. So when we had our diagrams, here, this is a proper fraction. In both cases, the numerator was smaller than our denominator. This is also a proper fraction. This is an improper fraction. This is also an improper fraction. If the numerator is greater than or equal to the denominator, the fraction is an improper fraction. An improper fraction is greater than or equal to 1. Again, if you are familiar with mixed numbers, I will accept mixed numbers as answers, but as you move up in mathematics, we will use improper fractions more and more and mixed numbers less and less. So I encourage you to get used to using improper fractions. Here are some examples. The 3 on the left are proper fractions. In all cases, the numerator is less than the denominator. All 3 of these represent a value that is less than 1. The things on the right are improper fractions. In all cases, the numerator is either larger than or the same size as the denominator. These all represent fractions that are bigger than 1. These are all simplified. Improper fractions are simplified fractions. Well, except for this one. We'll deal with that in a few minutes. But just because a fraction is in an improper form does not mean it is not simplified. Example. Here is a list of fractions. Let's first identify all the proper fractions in this list. Proper fractions have numerators that are less than their denominators. 3 is less than 4, so 3/4 is a proper fraction. 5 is less than 9, so 5/9 is a proper fraction. 12 is less than 25, so 12/25 is a proper fraction. 1 is less than 9, so 1/9 is a proper fraction. All of these represent values less than 1. Now we will identify all the improper fractions in the list. Improper fractions have numerators that are greater than or equal to their denominators. 17 is bigger than 5, so 17/5 is an improper fraction. 9 is bigger than 7, so 9/7 is improper. 3 is the same as 3, so that is improper. And lastly, 5 is bigger than 3, so that is also improper. A quick note about negatives. In chapters 1 through 3, we used a raised negative sign in the book. I, however, always wrote it with the parenthesis around it. Now the book is going to start using my notation for everything. In this case, this one means subtraction or minus, and this one means a negative. They will still use red to help indicate negatives versus subtractions, but you have to be a little more careful. A quick note about negative